Hey guys, Sun here. I'm a privacy and security researcher, and you're watching the Privacy Guides. This is episode 10 of the Bitcoin series. It is the last episode of the series. At the beginning of the series, I had a special announcement. If you know what I'm talking about, you know what I'm talking about. More on this at the end of today's episode. In today's episode, I want to talk about essentially how can one remain sovereign while one is alive, yet passing on a holding, for instance, or other sensitive pieces of data when one passes away. It's a topic that isn't sexy. It's a topic most people like to avoid, but it's a topic that too many avoid while they are alive, and people tend to not consider that we are not immortal and we can get hit by a bus, we can fall on our head and forget things. It's something that I really believe needs to be part of one's planning. No one, in the context of Bitcoin, when you're holding your own private keys, no one can really help you if you don't remember your password. But how can you solve that problem? How can you remain sovereign without having to hand over that password to people other than yourself? Well, that is a very hard problem to solve with normal cryptography. And it can't be solved using public key cryptography. It cannot be solved using symmetric cryptography. But thankfully, Shamir secret sharing is a scheme that can actually solve that problem in a very elegant fashion. Before I keep talking about this, as I've mentioned a million times by now, everything you read down there in the comments, that might be someone trying to steal your Bitcoin or steal your crypto. So please be mindful of this and help me report any spammy comments so that we get to keep the conversation going. I also want to send a warm shout out to ShakePay. ShakePay is a Canadian Bitcoin exchange that believes in the Privacy Guides project and has sponsored the whole Bitcoin series. Without them, all of this content would have never been possible. So thanks so much to ShakePay, and I'll link to them in the description. Now, I talked about multi-signature in the context of this Bitcoin series. Multi-signature is a fascinating scheme where you need to have multiple private keys in order to sign a transaction that will be broadcasted to the blockchain. Shamir Secret works in a similar fashion. It uses a special type of cryptography derived from mathematics that uses a curve, and you need more than one point on that curve to be able to retrieve a secret. I won't go into great detail on this. I'm not a mathematician or a cryptographer. You guys can read more about this. It's quite fascinating, but nonetheless, the cool thing about that scheme is you really need to have, if it's a 2 of 3 Shamir secret sharing scheme, you need 2 of those, what they call shares, in order to recover a secret. If you don't have 2, it is mathematically impossible to retrieve the secret. And the scheme is pretty flexible in the sense that you can have a 2 of 3, you can have a 5 of 7. I don't know what the limits are. I guess it depends on each implementation. Now, in last episode, I showed off what I believe is the world's most advanced paper backup hardware device that you guys can configure using a Raspberry Pi. That piece of technology, I am so proud of it. It's a piece of technology that actually uses Shamir secret sharing to allow users to create, 2 of 3 paper backups that can store Bitcoin mnemonics, for instance, or Monero mnemonics, but it can also store any secret that one can type with a keyboard. And it's done properly on a hardened operating system that is read-only, cannot connect to the internet. But it might be a little overwhelming for you guys to wrap your minds around, for those of you who are less technical, and maybe you don't just want to, set up a whole Raspberry Pi to start exploring with this. So I decided that in today's episode, I would kind of show how Shamir secret sharing works. It's not going to be an episode that is hands-on. It's not like I'm not going to show you how to install the command line utilities that I'm going to be using today, but all of them are mentioned in this how to create encrypted paper backups piece of reference material, which, as usual, I will link in the description of this episode. So the implementation that I mentioned here is, let me see, it's SSS CLI. It's an implementation that has been developed by a post-quantum computing PhD researcher who is called Dan. And Dan has created an amazing piece of software that is coded using Rust. And to install this, it's actually quite simple. You have to make sure that you have Rust on the computer, and then you just run this command. And now that this is done, it is possible to create shares. So if we look at this boilerplate example here, Let me see. I will go onto my desktop here. If I paste this in, what this is doing, it's echo. It's a command line that says, send Tyler burden isn't real to, that's pipe. So it's sending this string to secret share split. And it's a 3 of 4, I believe. We'll look at the documentation in a second. But then if I press enter and I look at this, now we have a piece of text here that's called shares, and you have all of your shares. So looking at this here, this is, let me see. So this is share number 1, share number 2, share number 3, and share number 4. So all of these shares, it's essentially a string that can be converted to a QR code, and that is what I'm doing in the context of this Raspberry Pi project. That is something that you can print out on a printer, or ideally convert to a QR code, which is much easier to import in the future. And you can really easily create shares. I mean, here's an example. There's another piece of code here. Let me see, QR code that we install using pip. So it's a Python library. It's called QR code. By the way, QR code also ships by default on Tails, and that is incredibly useful. So if I take, let's say, share number 4 here, and I type echo and I pipe this to QR, what will happen there, and that will likely blow up my terminal, but it will generate, it's not so bad actually, look at this. So it will generate a QR code right there into the terminal, but that's maybe not the best because you will likely want to print this. So if we run this and then we, let me see, we output the content of that QR to, for instance, a file. So we're going to call it share4.png, enter. Now on the desktop, let me see. Now on the desktop, we have a file called share4.png, and that can be printed on a printer, and that includes one of the shares. Now, showing this off a little more, and going back to the documentation here, if we essentially take the 3 first shares of that share.txt file, and we run this, it will regenerate the secret, Tyler Durden isn't real. But if we only take 2 of those shares, it will fail. Shamir secret sharing is a fascinating piece of technology. And by the way, Trezor, so this is the Trezor Model T. Trezor has done some outstanding work allowing users on Trezor Model Ts to, instead of backing up the mnemonic as one 24-word mnemonic, for instance, you can back it up using Shamir secret sharing. So they worked on an implementation. I don't know what the BIP model for this is, but essentially it will allow us, or it allows us to create X of Y shares right out the bat using this. Now it does it in a way where you have to write it down on a piece of paper. So, and it's not encrypted. I talked about all of this in the context of last episode. So I would watch that one first. It's episode 9 of the Bitcoin series, but nonetheless, it's amazing that you can do this stuff right there on a hardware wallet. But now, as I mentioned, this episode is not only for Bitcoin. So as you saw here, the secret is essentially a string. So that could be one of your passwords. For instance, it could be the password to your computer. Now, clearly doing this kind of stuff in the context of Bitcoin on a Mac computer is reckless, because that computer might have some kind of a backdoor on it. It could have a keylogger. It could have some kind of a screen capture vulnerability that's running on it. So that is why I went through the immense trouble of setting up that Raspberry Pi project. But for us to kind of learn about this, that's why I wanted to show this off in the context of running this on Mac. I'm sure this kind of stuff can be installed on Tails OS, which would likely be a much more robust approach. I might create an episode on this. If you're excited about this kind of content, smash that subscribe button if you're not subscribed, the like button just to show that you guys care about this content. And please feel free to comment if you have any ideas on this. So essentially, we're gaming the algorithm here. Cool. Okay, so hopefully that was insightful. Shamir secret sharing is the best solution that I've found so far to create estate planning. So essentially, it is possible to create, a set of, strings. So essentially, like dump your passwords, dump passphrases for Trezor devices, dump mnemonics, whatever you want, into one of those Shamir secret sharing schemes, and then generate QR codes, print them on a piece of paper, and then make sure that those pieces of paper are away from sunlight and in a waterproof bag. And then you can distribute those to people that you really trust, but you don't need to trust a single one of them with the full secret. You trust essentially a governance party that you get to establish. So this is such an amazing piece of tech. So yeah, as a quick recap of this whole Bitcoin series, I mean, we had a look at how to set up Bitcoin holdings securely. We did this on macOS using Electrum just for people who want to get started without buying hardware wallets. We discussed why hardware wallets are so mission critical and how we need to be mindful about how we use them, how using a passphrase on hardware wallets makes the hardware wallet so much more robust. It allows us to have plausible deniability. Mention why you should always use these pieces of software over Tor, because you do not want to divulge your real IP address to people running nodes that could be nation state surveillance programs or just bad actors in general. We talked about how to create encrypted paper backups and why it's super important. And now we talked about essentially how to use Shamir secret sharing schemes to put together plans so that if ever one loses our mind or one gets hit by a bus, our loved ones will have access to our holdings. So as I mentioned at the beginning of this episode, I had this kind of game going. Anyone who is down to count the amount of times I say Bitcoin in each episode and then have a grand total of that, send that over by email. So send the total number of times I said the word Bitcoin in the whole series. And I will be sending out to you if it's legally possible, by the way. So there are legal constraints. I don't want to get in trouble here, but I will be sending over 2 Trezor ones so that you get to set up your own multi-sig holding. Thanks to Trezor, by the way, for sending those over. And I decided I wanted to share some of this, some of these gifts I had with you. So yeah, send that over by email if you want to participate. And I will see you very shortly in normal Privacy Guides content. Actually, I am forgetting to show you this Raspberry Pi thing. Okay, I will use, so this is it. I did share this special announcement, but before I let you guys go, I'm not sure if I mentioned this in this take because I was recording the other one and then I unplugged my SSD hard drive and everything kind of blew up. So in last episode where I showed off that Raspberry Pi project, clearly everything was really small because I was showing it off on the beautiful little Adafruit screen, but it was probably not very intelligible. So I want to take a moment to kind of show you how this works here. So I plugged in the Raspberry Pi using the HDMI output into my Mac. So going back here to the usage guide, as I mentioned, if you run QR backup and then help, so I need to switch keyboards here. QR backup. Oh, sorry, I have to log in. Okay. So QR backup -- help. Boom. You can see what you get to do. So if you want to create a Shamir secret sharing backed up or Shamir secret sharing paper backup, sorry, this is what you would want to do. So you would essentially run Shamir secret sharing and then number of shares. So number of shares, if it's a 2 of 3, you would put 3 and then share threshold 2. Now you can actually select a label here. So I'm going to call it test, okay, and then enter. So once you do this, it will ask me to format the micro SD card that I have plugged into my keyboard. Whoa. Okay, so now it asks us to type a secret. So that can be anything you want. So as you saw here, this Raspberry Pi can actually generate a 24-word BIP39 mnemonic. It can also generate a 24-word Electrum mnemonic. Could be cool actually to add Monero support to this. But yeah, now, so say the secret is Tyler, okay, Durden isn't, whoa, how do I do this on my English keyboard? Real, okay, enter. Control D, Tyler Durden isn't real, Control D. Now we get to type a passphrase. So one of the big differences between the Raspberry Pi setup versus what I just did using command line is when you generate shares, they have a cryptographic signature. So someone who finds shares can identify that they're related. Now we did set a label, which kind of means that they're related, but you don't have to. They can be totally random. So by using GNU-PG to encrypt the output of a share, so that is what we see here. So in order for this not to have a pattern, because part of it is always identical between shares, that's how the SSS CLI implementation is done. I decided to encrypt it as well, and that also allows us to have that encryption passphrase, for instance, in our testament, and then everyone has shares. But anyways, you guys have ideas about this. That is kind of weaker, because then if ever the testament is lost, well, one cannot access those shares. So that's really up to you to put in place a system of governance and a system of security that matches your needs. But essentially here, if I put a passphrase, enter, no, it will encrypt shares. And as I showed in last episode, those shares are then on a piece, are then stored on the USB flash drive. I hadn't rehearsed for this part of the episode, so as you can see, I'm looking for my words a little bit here. But yeah, now we have this on the little USB flash drive. And if I plug it in, let me see, no name, we now have those 3 shares here. So not only are those protected using this beautiful work by Dan, but they're also encrypted with a passphrase. And as you can see, through how they look, there is no pattern. So if you don't add that test label, it's impossible for someone to know, if they don't know the passphrase, that these paper backups are related. All right, super excited and pumped to get back to privacy content. I have a whole bunch of things that I'll be sharing shortly, so stay tuned and I will see you soon. Bye.